You have people joining from India, you have people joining from different parts of India rather, then people joining from Germany, people joining from Canada. We're also working in USA, so it's nice to have so many people of different geographies. I believe you guys might be accommodating different time zones. Since in India we are starting late at 9 o'clock in the evening. For some of you guys, it might be morning. So thank you again for putting that effort to improve your learning curve. And now let's get started talking about the course outline for this training. What exactly are we going to cover? Right. I'll give you a brief intro about that.
So, Abhi, can I make just one
Yeah.
comment, please?
Yeah. Yeah. Please.
So, because it's my working day, and I think most the people who are from North America, I think it's their working day, is their work day. So I
Yeah.
might not be able to take or focus on the entire class every day, but then the
So,
recordings are going to be very
are
important for me. So,
yeah, that's correct. No problem. No problem. Please accommodate this class as uh, how it is comfortable for you, which
yeah,
suits your schedule. Yeah. But then be active in the Telegram group. I mean, I will highly
sure,
encourage you to do all the lab activities that I do demonstrate in the class, so that you keep
great.
up with what we are learning. And then if you face any difficulties while you are practicing, since the lab access is going to be available throughout this training course 24/7, if you face any difficulties, just you can raise your queries and share a snapshot of the problem that you're facing in the Telegram, and myself and the team will be there to help you guys.
Okay, thank you.
Awesome. All right, let's talk about what exactly are the things that we're going to cover in this training. So, the very first thing that we're going to talk about is the introduction.
So I have one question. So may I?
Yeah, yeah, please go ahead.
Actually, to go through SD-WAN, is it necessary to have CCNP knowledge as well, or we can
No,
go
no.
through?
You just need to have a basic idea, however, a good detailed idea about how networks really, how routing and switching really works. If you're good understanding the routing protocols, if you're good understanding the switching protocols, then I think that is all that we're gonna require for this course. Yeah,
Okay, okay, fine. Thank you.
awesome. The very first topic is gonna be introduction to SDN, and SDN stands for software defined networking. So so there are traditional networks which organizations still chooses to manage, or by using CLIs, by using traditional methods, where an independent network engineer might be communicating with that network device either by using console access or by using remote management sessions, right, like SSH and all, and then perform device by device configurations. This is called traditional way of managing network. But then there has been limitations, there has been challenges, and then in order to overcome those challenges, we have got SDN as our solution. So SDN, which is software defined networking, uh, can be used in order to manage or in order to decouple control plane and data plane, right? And then also management plane, and centralize the management of your entire fabric, your entire devices in a single pane of glass. And then based on this architecture, there has been very like many solutions which has been released by different vendors, including Cisco, including Juniper, including Fortinet, including Sienna, Checkpoint, Palo Alto, and whatnot, right? So our motive is to understand how the core technology, what is the architecture of SDN, on which the SD-WAN solution is based, right? So we will spend a good amount of time understanding how SDN works. This is kind of a common topic which I do deliver for most of my trainings, which has automation as the baseline in it, right? So understanding SDN is quite important for us. Then once we have the understanding of that, then we're gonna get started with the fundamentals of SD-WAN, or introduction to SD-WAN, whatever you call it. In this, we will try to understand how networks have been managed by using legacy techniques, right? Then how things like intelligent WAN came on, or IWAN came up, and then how the need of SD-WAN is required, and then how what exactly are the benefit that SD-WAN as a solution introduces to your traditional way of managing the enterprise branches, right? And then what exactly are the components and all that stuff. So once we are able to differentiate the challenges that we have in managing the network from a traditional point of view, and how SD-WAN helps you there, then we're gonna talk about the uh, components and architecture of SD-WAN. In this section, we are going to understand how the uh, components of SD-WAN works, which includes the vManager or vBond or vSmart, right? And in the latest release of SD-WAN, we also talk about the manager. vManager now have been rebranded to manager. vBond have now been rebranded to validator, and the vSmart now is managed. Rebranded to controller. So we understand how these components really works, and we also understand how vEdge or WAN edge devices can become part of that particular fabric in an automated way to form the SD-WAN fabric. So we understand about the components that are there in the SD-WAN solution. Then we understand the architecture that it uses. So more or less, the SD-WAN solution uses the architecture of SDN, since it is kind of the child solution of the parent called SDN. SDN is kind of an umbrella technology. Within that, we have lots of SDN based solutions that we know now. So these are three things that we're going to talk about. And then the fourth pointer is going to be the control plane and data plane operations. Okay. In this, we dive deeper into the schematics of how the automated discovery of branches, the automated discovery of vantages, the automated um, formation of site-to-site tunnels really is done uh, in the SD-WAN solution. What is the protocol that offers the same, and what exactly is the logic that actually does all this automation using the protocol called OMP, which is Overlay Management Protocol. That is Cisco's proprietary protocol for this particular solution. So we're gonna dive deeper into this OMP thing, and then all these four topics. These four topics basically are the theory topics that we're gonna cover in the next couple of classes. Okay, or next 2 to 3 classes. Post that, we will be jumping straight into the labs. But then, hear me out carefully. If you understand these four topics very well, then you understand 40% of what the SD-WAN solution is all about, right? And you improve or increase your chances of passing your exam on the first attempt itself. Many of you uh, might know, and everyone should know, that whatever content that we're going to cover in this training, it straight away focuses on the enterprise concentrated certification for SD-WAN, right? So learning these four topics in depth is very fruitful for you. And then we get started with the implementations. So once we understand how the solution works, then we go for the control or controller side onboarding. So this is where we onboard our vManager. This is where we onboard our vSmart. This is where we onboard our vBond and certificate authority and everything else, right? So we talk about the theoretical aspects of how the onboarding really works, and then I'm gonna show you a demonstration of onboarding the controllers from the scratch, right? Nothing is gonna be there on the configuration. Everything is gonna be configured fresh on the topology by me and by you as well. Once that's done, then we move forward and then we onboard the or branch onboarding or branch site, right? So we're going to use the WAN edges, the Viptela VH devices, as well as the Cisco's WAN edge devices. We're going to use both of them in order to onboard different branches. So some of the branches might be using Viptela VH. Mostly we're going to use Viptela VH because it is lightweight and it is reliable for our lab purposes. But then since we are also supposed to learn about how Cisco's WAN edges are onboarded, we're going to do that also, right, in our lab. So both types of branches will be onboarded using we will also understand how the PNP method works, right? Plug and play or zero touch provisioning. How does that work and how do you really use them? Once the branches are going to be onboarded, then the branches are automatically going to form overlay tunnels with the other branches. Like if you have 5 branches, then all these 5 branches will form tunnels with each other, which are going to be secure data plane tunnels like IPsec tunnels. But in order to make communication, you actually have to use something called service VPNs. So that's exactly what we're going to do next. We're going to do establishing site to site communication using service VPNs. Okay, there are different types of VPNs available, including service VPN. You have transport VPN, you have management VPNs. We will understand their roles and how do you really work with them. But then if you want to enable communication between multiple branches, using service VPN is kind of crucial for you. So that's something that we're gonna learn. Post that, we're gonna also enable the direct internet access capability, which is also called as DIA. And DIA has 2 subtypes. So you have something called central internet breakout, called as SIP, and then you have local internet breakout, called as LIB. We're going to talk about both of these, just like how the previous topic enables the capability of making communication between the branches, right? But what if the endpoints which are connected to your branches needs to communicate with internet? How do you provide that access securely? So this is where direct internet access comes into picture. We're going to learn that, we're going to understand how it works, and we're going to deploy that in our lab. And after that, we start with uh, the important thing called Cisco SD-WAN policies, right? So there are lots of policies. So when your fabric is deployed, when your fabric is working just fine, then you definitely need to fine tune your network so that the fabric can behave as per the expectations in an optimized way. So there are lots of types of policies. You have centralized policies, you have localized policies, you have control policies, we have VPN membership policies, right? Then you have data policies, application aware routing policies, QoS policies, ACL policies, service chaining policies, lots and lots of things, hub and spoke policies and whatnot. All these policies to fine tune and manipulate your fabric is something that we're going to learn, and we're also going to try and implement that, right? Post that, we will talk about another concept, which is going to be T-lock extension. This is about How do you really provide the connectivity of one WAN link to the other device in the same site so that you save a lot of money in that scenario, right? That is something that we're going to talk. And post that, we're also going to talk about the high availability. How do you really deploy advantages high availability? How do you really deploy controllers high availability? And that is something we're going to discuss as well. So this is what the majority of the topics that we're going to cover in this particular training. All these topics contains a lot of subtasks, right? So when you explore all the subtasks which are associated with these major topics, there is a lot that you're going to learn. And like I said, the first four topics are going to be theory, right? But the last, about whatever the number of topics are, all these topics are based on lab exercises. So lab plus theory, I would say. And each participant receives a lab pod. So how does a lab pod looks like? If you look at a lab pod, then each participant will receive one called Windows jump host. That jump host is connected out to the internet from our data center, and it's going to be unique for every participant. And then you have a user sitting anywhere in the world trying to access to that particular jump host. The credentials for the same are going to be shared with you well in advance. And second, you have a network simulator called EVE-NG. EVE-NG is kind of a network simulator that is used to deploy the SD-WAN topology, right? And then the Windows Jump Server and EVE-NG are bridged together with a subnet also, so that the Windows machine can communicate with those particular VMs if it's working fine or not, or nodes if it's working fine or not. So this makes one lab pod for every participant available. If someone messes up their configurations, their topology, and all, is it going to affect your lab? Not really, not at all, because all the participants do receive their own lab activity. If they mess up their lab scenario, they're going to cause only their lab. It is not going to affect the other labs which are there. Yeah. And that is about how the lab implementation is going to be. If we talk about the topology, what we're going to talk about, then we will kind of have a controller side, right? For example, you have your vManager, your vBond, your vSmart, your certificate authority. Everything is connected to maybe device, and then that device is exposed out to maybe ISP1, and then it is exposed out to maybe ISP2, right? And then you have lots of branches. So you have branch number one, you have branch number two, and maybe you have branch number three, where the branch number one has like WAN edge one, which is connected to both the ISPs, and then it has a LAN segment also. Similarly, you have maybe WAN edge two connected to both of them, maybe like WAN edge three, which is only connected to INET, WAN edge four only connected to ISP2, and then maybe have a like a LAN segment locally. So how do you make communication? Whenever you make communication from this LAN to this LAN, it is considered to be a site-to-site communication, right? But when you're gonna make communication from here out to anywhere in the world, it is considered to be as internet-bound communication. So you need to facilitate all these configurations in your lab environment. And that is what the outline is going to be. That is how the lab will be assigned. That is how the topology is going to be built from scratch. Questions any? If you have, please feel free to ask. I could have gotten started about the first section, but I think I'm going to keep this particular first day very easy uh, because we started off late. I also need to eat something. I haven't had anything since morning. Uh, So what we will do is we're gonna cut this short today. We're gonna keep this to the introductions only, and from tomorrow we're gonna get started full fledged at 8:30 p.m. in the evening, and we will get started with our first topic today, and then for the next two classes we will cover the fundamentals, the components and architecture, and the control plane and data plane operation. So for week one, we need to wrap this theoretical discussions entirely, right? And once we are done with that, from next week we get directly into the lab deployments, right? So you shall soon receive the credentials for the lab. The recorded sessions are going to be accessible on our learning management system. So the those of you who have enrolled with PyNet Labs for the first time, you're going to get a fresh email, uh, which will require you to create an account on our LMS portal, right? But those who already have attended some of my or someone else's training at PyNet Labs, your same account will continue to provide you a new course, right? And that particular course is going to be SD-WAN, which you will be able to see all the recordings of. And the Telegram group, of course, you must join that Telegram group because it's going to be the point of contact after the class hours. So if you if you face difficulty while doing any of these, please drop a text to Nitish and he shall take care of helping you.
Our topic, which we're going to discuss about, is going to be introduction to SDN. And if we have time, we will also talk about the fundamentals of SD-WAN and what it exactly does. But first, let's get started with the very first topic, which is going to be introduction to SDN. So most of you definitely might be knowing the full form of SDN, right? The SDN stands for Software Defined Networking or Software Defined Network, whatever you call it. So this has always been a buzzword in the IT in the last decade, for last 10 years or 15 years, I would say, right? And uh, whenever you hear about this particular terminology, people have mixed reactions. Somebody have already taken up and understood what SDN is all about, and he or she feels comfortable working with whatever solutions that have been developed under the umbrella of SDN. Some people who might not have had a chance of understanding what SDN is, they kind of struggle to understand its motive, to understand its capability, and all that. And that is exactly why we have taken this topic as a prerequisite and as an important discussion before directly jumping into SD-WAN. So, in order to understand SDN, which is a newer way of managing your network infrastructure, first you also should know how the traditional networks are managed, right? So, when you think about traditional networks, right? When you think about traditional network, then networking has been very traditional, right? So we have specific network devices which we use in our infrastructure, like we have routers, then we have switches, then we have firewalls, we have load balancers, we have IDS, IPS, right? Then we have certain other devices. And all these devices are manufactured by different organizations like Cisco, like Sienna, of course, like Juniper, then maybe Checkpoint, Palo Alto, F5, and whatnot. Huawei, Nokia, Aruba, Arista, so many other vendors are available. The network devices are sold by these networking vendors, right? Like Cisco, and they often use proprietary hardware. And most of these devices primarily are configured through the CLI. However, there are some GUI products also, right? For example, so whenever you kind of have a device, let's say we have a normal router. Now, how would you deploy configuration on that router? You would definitely connect that router with maybe an admin PC, and then let's say this is kind of gonna be your console cable, right? And this is gonna be your console port. So once you connect that particular cable to the port, you are going to execute the or send the CLI commands, and then the device will be configured as per your expectations. On the admin PC, what is the utility that we will be using? You can use utility like putty or super putty or mputty, right, etc. So it is all these are all utilities which you can use in order to create a console channel with the device. And then you can send your commands and then the device will be configured. But is this the only way how we can do the config? Not really, right? Because you can expose this particular device to maybe the ISP or to the internet. And then there can be someone like a remote admin user who can create SSH connections, who can create telnet connections, or who can even create HTTP connections to send the same level of CLI commands. And this approach will also allow you to configure the device properly. But what used to happen, so I'll give you a little bit of backstory. Now, we see that almost all the organizations deploy the network infrastructure, which has like devices from various vendors. You will very less likely see that an entire production environment is made up of devices from one vendor, right? So the organization probably might purchase these routers or firewalls from one vendor. Like let's say routers come from Cisco and switches come from Aruba and firewalls come from maybe Fortinet and load balancers comes from F5 and so on. So whenever this procurement happens, the organization will also start looking for people who knows how to deploy these devices, who knows how to work with these devices. And that is where network engineers like us come into picture. So we go and then we deploy these devices, depending, I mean, given that we already are familiar about how to configure the required vendor's devices. Now, if there is someone who knows how to configure Cisco's devices as well as Juniper's devices as well as Palo Alto's devices, then that particular person carries more value from the context of or from the perspective of your employer, right? Uh, and then someone who only knows how to configure Cisco's devices or any other specific vendor's devices, but not many of them, then that particular person acts as a disadvantage, right? And that particular person might not have as much of the value as the other person knowing all the other devices configuration methods would be. So this is why network engineers also starts learning about new technologies. They start learning about new ways. They start learning about new configurations and blah blah blah, right? But then it is not just about learning, right? For example, it also puts a toll on network engineers' mind to remember the syntaxes of how an IP address is configured on an interface when the device is made up of Cisco or Juniper or so on, right? Or mix of all of them. So it gets difficult. One particular person should know how to configure the devices of Cisco as well as Juniper as well as other requirements. Then only that particular person carries any value. But then uh, kind of requiring network engineers to upgrade their skill sets at this particular level also introduces risks because the device probably might not be in the best shape, or the device probably might require a different syntax to be used for that particular config, since the syntaxes which are used on different devices are different. It's not going to be always same. Then if I go to interface gi0/0 and then say no shutdown, then IP address and whatever it is, the IP is gonna be, or the interface rather, is gonna be configured. But can you do the same with other vendors' devices? Not really, right? So probably you'll have to use other commands and other methods. And this is where we need to think that is it okay to let a network engineer upgrade himself or herself with all the vendors and all the syntaxes and everything, because it definitely can introduce risks. And this is why uh, organizations also started introducing GUI access. So if you have heard about one of, I'm sure you definitely might have heard about it. So Cisco has one of the device called ASA, right? Adaptive Security Appliance. So the ASA, when you connect that particular ASA with its out-of-band management interface to your PC, then you can actually configure the ASA by using CLI method as well as by using GUI method. If you want to use CLI, then on the for PC, you're going to have softwares like Putty and Mputty and all that. But if you want to configure the ASA with the GUI, then this is where you require a tool called ASDM, Application Security Device Manager, which allows you to access the GUI very easily, log in into that particular portal again very easily, onboard your firewall or whatever device that you're trying to get onboarded very easily, right? And then probably make configuration changes accordingly. But if there is a network engineer who knows the logic behind the type of configuration that you're doing, but he or she does not know what is the syntax that I'm supposed to use to configure an ASA, well, this is where the GUI comes to rescue then. So you can just access the GUI of the ASA firewall and you can configure that entire firewall without knowing any single command, because you will only be using the graphical user interface to define the configuration parameters. It is that easy. So organizations started to introduce such kind of GUIs to all of their products. So Fortinet also has a GUI, Checkpoint also has a GUI, F5 rather also has a GUI, right? And then network engineers started using GUIs on lighter note. And this is another way of doing that configuration, right? Not just CLI, but without knowing the CLI command, you can still deploy or kind of validate whatever configuration is present on that box. Now, in this case, you also need to think this is from the management perspective. Now, from the configuration perspective or executional perspective, the devices which you deploy in your production environment, they have a lot of jobs to do, right? When I say jobs, I mean the processes which you execute. So the processes can be BGP, the processes can be OSPF, the processes can be EIGRP, ACL, whatever it is, right? And think of a very simple network, I will say. So if I say you have a router, that particular router is connected to some switch and then some endpoints. Similarly, you have another, oh, sorry. Similarly, you have another router which is gonna be router 2. And then that particular router also has, yeah, reachability. So this network is kind of gonna be 192.168.1.0/24, and this is gonna be 192.168.2.0/24, and then connect both of these together, maybe using a network called 192.168.3.0/24, and assume that you already have static routing implemented on that. What does it mean? It means that by implementing static routing, you will probably add the 2.0 as a route into R1 and 1.0 as a route into R2 about what their next stops are. And then the whenever the traffic gets forwarded, like from here, the traffic will go to the router, then to the switch, and then down to the endpoint. This is kind of going to be the usual path. But if you have any backup, if you have redundancy, if you have other things, you actually need to configure all of them. But does it mean that the routers are only used for forwarding traffic from one point to the other point with the best of their capability? Not really, right? So a network device, like let's say we've been talking about router, right? So a router has different functions that it has to perform, right? Think for a moment about some of the things that a router has to do in order to forward the packet, right? One, you can say that it has to, first of all, uh, enable itself with routing protocols like OSPF, EIGRP, BGP, and all that. And then it also has to build a local, maybe BGP update or other packets which are there. And then what's going to happen is every time the router is actually going to cross a hop, the TTL value is going to be decremented. So whenever a packet comes in, inspect that packet, decrease the TTL value by one and send it again. Likewise, let's say that you have to check the destination IP in the routing table, whereas every traffic, when it gets forwarded, it actually gets validated that if your existing router, maybe your gateway it is, it has to configure or it has to know whether you have a specific route for the destination or not. If you don't have one, then you actually have to create one, and communication between these devices will further be terminated, right? Similarly, like I said, it has to decrement the TTL value for each packet by one. It also has to use the ARP to figure out your destination MAC address of what the IP you have provided for the next stop and so on. So in such cases, uh, there are lots and lots of jobs that a router, be it a firewall, be it a switch, whatever it is. These devices needs to perform their job they have been assigned to. And in order to better kind of execute these jobs, there are three planes. So the user sits over here, right? And then the user kind of bidirectionally communicates with the first plane that is gonna be management plane, right? Second, it is gonna be control plane. And third, it's gonna be data plane. So these are the three planes which every device do have, be it a router, be it a switch, be it a firewall, be it access point, be it WLC, whatever it is. When you think about the management plane, as the name suggests itself, right, that the management plane is used to access the management of your device. For example, accessing your device through SSH or through Telnet or through console port, right? And when you access these mediums, you will actually be able to communicate your intent to the executor of that configuration, right? So let's say the management plane got the information. Now what happens is the data goes to the control plane. So the control plane is responsible for exchanging the kind of routing information, the routes, the route updates, dead timers, whatever it is. It is all done by the control plane. It is kind of the brain of the entire device or the entire topology. And then you also probably might have other jobs like running spanning tree protocol to create a loop-free topology if it's a switch, or building the ARP table, right? Or running the routing protocols. All these particular jobs can be thrown at that particular device if it's a router. Maybe if it's a switch, the jobs might be different or so on. But the handover of the job happens from the management plane to the control plane, right? Once control plane receives that particular device, then it starts acting upon it. So maybe uh, when that happens, the encapsulation and decapsulation of packets will happen. Adding or removing the headers like .1q header from the switches map frame is gonna happen, or matching the MAC addresses for forwarding is something that is taken care by data plane, or changing the source and destination IP address of the packet using network address translation. All these things happens at the data plane, right? So they're interlinked, I would say. The user interacts with the management plane. The management plane interacts with the control, and control interacts with data. Management cannot at all interact with data. Neither data can interact with management. Data only has the permission or capability to speak to control. Control can speak to management. Management, of course, is going to speak to the user. So these are three planes which are available. Now, this is exactly where the risk comes up into picture, right? Like, why do you require STL, right? So these are kind of the normal behavior and environment of how devices functions. But now, any questions still here? Please feel free to ask. You can raise your hands if you have any questions so that I can ask one by one if there are many questions. Okay. Uh, those of you who feel that you are completely fine with whatever I have explained, you can prefer giving a thumbs up. That helps me understand that we are going good. But
Yeah, I have a
yeah,
question.
somebody have a question. Yes.
So actually, in between my internet stopped working, so I just missed
Mm-hmm.
these 3 points: management plane, control plane, and data plane. So can you
Yeah.
please
So
repeat them?
yeah. So management plane is basically a plane. So all these three planes are available on all the devices. Okay. In management plane, the management plane is basically something which allows you to interact with the device. So it can either be via console or it can be via remote sessions, right? Or certain other thing. So I mean some other thing. If you're accessing the CLI or GUI of the device, you are interacting with nothing but the management plane of the box. Then using that management plane, you're going to pass on your kind of instructions, and then the control plane will act upon it. So the control plane can get the results for forwarding the traffic from one point to the other point with the best of its capability, right? Or certain other things that a control plane might do is running the spanning tree protocol or building an app table, right? Or forming a routing table for forwarding the traffic and so on. And data plane is something which is responsible for forwarding the traffic from one point to the other point. So be it encapsulating the frames, or be it stripping the old Mac and putting the new Mac and so on. All of these are things which are done by the data plane. Make sense, Faisal?
Yes, sir. Thank you.
Yeah. Next, we have a question from Bharat. Please go ahead.
Hi. I
Mm-hmm.
have a small confusion between data plane and control plane. Both are
Mm-hmm.
doing the forwarding, right? Traffic forwarding.
Control plane does not forward traffic. Control plane takes the decisions for you. Then those
Mm.
decisions are informed to the data plane, and data plane forwards the traffic.
Mm. Okay. So the
Make
control
sense?
plane only controls. It's like
Control
it should
plane, yeah,
not
does the
forward.
brain work. Like whenever you receive a route update, then to install that route update in the routing table or in the forwarding table, it is the
Mm.
job of control plane. But then whenever the receiving traffic is being inspected, then
Mm.
figuring out what is the next stop and what is the MAC address of the next stop, and then actually putting the traffic on the cable, that is something which is done by data plane. It is not done by control plane at all. But control
Okay.
plane is the one who decides which is the best path. One of the kind of tasks it does along with the others. Make sense? Bharat?
Yes. Yes. Yes.
Perfect. Someone else also had a question, but I guess you love what you had. Who was that? Okay, looks good. If I try to explain this case in even an easier manner, think of it this way that you have, let's say that this is your main device, right? Now a user is sitting over here. A user interacts with the router one. Now let's say that this is kind of your management plane. So you have CLI or GUI access. Then this is where your control plane is gonna be. Let's say your control plane has OSPF, EIGRP, and maybe a static routing runner. So what these processes will do, like OSPF will build its own neighborship table, and it is also going to build its LSDB, right? Links state database. The EIGRP is going to build the topology table and neighbor table again. Static routing, however, does not create any such table. And then out of that, you're going to have something called a routing information base, right? Which works in conjunction with ARP, address resolution protocol. So what happens is like the best route from the routing table goes to LS, the routing information base. The best route from topology table goes into the routing information base. And then that same information will be conveyed down to data plane, which is nothing but forwarding information base, right? FIB. So all the interfaces, they are kind of attached here. You have gig 0/0, gig 0/1, maybe gig 0/2, gig 0/3, and so on. If there is any ingress traffic, like traffic comes in, now the forwarding base is nothing but a copy of routing base. So it is going to make decisions based on the local forwarding table that whether the traffic should be forwarded, and if yes, then on which interface it should be forwarded. So that's a decision which will be made, and then the traffic is gonna be forwarded. If it's all the way a new case, like a new customer is requesting something, then you definitely do the background checks and everything else, and then enable that capability. So this is how a general kind of architecture of how your device really looks like. Now, what you need to understand is what exactly are the limitations over here, and how does SDN solves that particular purpose. This is what we need to understand. So I'll give you a very easy to understand example, which is kind of my favorite. I usually discuss this example in many trainings. So if I look at like challenges, or rather limitations of SDN. So in this, let's say that we have an ISP and that particular ISP provides connectivity to your data center, which has server farms. But for now, I will just keep one server, and that server, let's say, has some VMs installed. So maybe it is an ESXi based server. So I'll say VM1, VM2, VM3. And then you will also have to provide reachability. So maybe you have border routers over there like R1 and R2. Then you have firewall 1 and firewall 2, maybe layer 3 switch, and then layer 2 switch. And then connect together. And then you connect both these devices up. You probably might have the mesh topology implemented, but this is like one of the approach of designing. If even if you create this topology and even if you start using this particular topology, you will find out that there are limitations. Number one is all the configuration that you do has to be router by router, has to be manual. Second is it makes that particular network very slow. Third is you increase the risk of kind of you need to, I mean, you kind of raise the risk of not being able to configure the device in an optimized manner, like error proneness. So if you do router by router config, then doing a simple configuration takes a lot of time. Maybe your manager have asked you to create a report on how the utilization of your networks has been for the past month or maybe for the past 2 3 months or so on. So when you are required to create this particular scenario, in this case, you need to think of how you can optimize it, right? And if I also say that this ISP also provides connectivity to your Delhi office and maybe your Noida location, let's say. You have R1, R2, LAN segments, and so on. And you need to provide connectivity so that people who are sitting in Delhi and Noida location, they should be able to access these VMs because what these are business VMs, which means some might have ERP solutions, some might have CRM solutions, or so on, right? So we need to definitely solve it. Now, if I go and try to make configuration changes, I will have to make sure that all the changes are incorporated by all the devices. That's the, which again creates a bug over there that all the configs are, yeah, all the configs are basically being done device by device, and they're not fail proof. It is possible to have some errors and so on. So this is where SDN comes into picture. Now, in our case, in the traditional scenario, all the devices over here in the topology, like routers and firewalls and switches and whatever it is, all of these have their local management plane, have their local control plane, have their local kind of data plane. But if you look at the 1 minute, yeah. So if you look at like the SDN architecture, then what happens in SDN is over here you're gonna have a PC. That PC is going to interact with, rather I will call it controller, and then down below you have the infra, right? Earlier, what used to happen is there didn't used to be any controller or any layer. So you will directly interact with the infrastructure and then perform whatever conflicts that you want to do. But now you cannot. Your PC needs to tell to the controller that what exactly is the config that you want to do, what is pending, and all that stuff, and then provide a handover. But here now, since you see, all the infrastructure devices will be managed by the controller. So you interact with the controller either by using GUI or by using CLI, whatever medium it is. And based on that, you basically get to know that this way also you can make communication. So you tell all the intent to the controller. The controller converts that particular configuration into device understandable language, and then it pushes that, or he or she pushes that particular configuration there. And then the device will start behaving accordingly. But then over here, you don't achieve, I mean, if you keep it traditionally with only that benefit, then you will not have redundancy. You will probably have to have basic configurations done manually and all that stuff. So this is where the SDN architecture comes into picture. So you as a PC owner needs to tell your intent to the controller. The controller will convert the given intent to the device understandable configuration based on whatever devices you are managing. And then the infrastructure will be configured. So if I say that, let's say I want to configure OSPF. So I go and interact with the controller. Can we configure OSPF? Controller says, yes, we can. PC says, okay, I want to configure OSPF process number one on all the device. Then I'm going to say, I want to configure OSPF process particular one. Then the interface GI1 needs to be part of my area, whatever 10 area or something like that. So when this particular scenario happens, you provide your intent to the controller, and then the controller understands that intent and makes the device's configuration ready. Once the config is ready, you can actually push that config on one device at a time or many devices at a time. That's totally your call. But then such kind of capability is not there in the traditional way of managing networks. So many people still kind of misunderstand that SDN is something which has been bought into the industry to optimize how routing protocol works or to improve how BGP works or so on. Not really. Earlier, this was the motive of SDN, but now it has changed to SDN being only a management, a portal which centralizedly allows you to manage your infrastructure, right? With which it brings a lot of benefits. So this is what SDN is all about, right? It is about the architecture that you see, that you connect with the controller. Controller will connect to the infrastructure. You do not get to directly make communications. So there are two types of communications which happens in the controller, right? You can divide it diagonally like this. If I have PC to control communication, then it is northbound communication. And when the controller communicates with the infrastructure, this is gonna be southbound, right? And that is how SDN works. So it is, people still misunderstand that it is kind of a physical device or a software update which is going to change how OSPF forwards traffic or how BGP sends route updates or so on. No, right? SDN is only there to increase how you manage or increase the performance of how you manage your network, right? So that is where the scenario comes in. Any questions still here? Please feel free to ask. So where does SD-WAN comes into picture? So in order to understand the uh, nature and capability of what SDN really or SD-WAN really does is think of that you're an enterprise, right? So an enterprise is going to have few branches. What you usually have is, let's say you have branch number one, enterprise A, branch one. On the branch one, you have your core router. And similarly, you have branch two, and that's where your core router is. And at the back end, you have few LANs, right? So this is your sales network, marketing network, maybe operations network, right? This is also sales, marketing, and ops. And people in the sales network wants to communicate with the sales network of the other branch. So what you will mostly do is you will actually contact an ISP and see if that ISP can provide you connectivity between your branches, right? So let's say this is the ISP. Now ISP have invested into network infrastructure in a way that they have laid down their physical cables, their physical infrastructure to provide connectivity from one point to the other point. And at every branch's nearest location, you have someone called provider edge router, right? So let's say this is provider edge number one, and this is provider edge number two. We call the core router as customer edge router or C router, right? So the P router and the C router are connected together by using some BGP neighborship, eBGP neighborship, or something like that. And then internally, there are going to be multiple routers. So maybe you have router one, router two, router three, router four, maybe router five, and router six. And then you have connectivity like this, like this. So this is kind of a simple idea of how ISP networks really look like. So whenever the traffic is gonna go from sales network to the provider edge router, the provider edge router can forward it this way, can forward it this way. This can go to here or here, can go to here or here, right? Or here or here. So there are multiple ways of forwarding your traffic from one point to the other point, right? If the primary path fails, the secondary path for sure is there. Now, in this case, whenever, so you are actually going to subscribe to your ISP's network. Now, whenever any customer considers few points when subscribing for the ISP link. So one is if it is affordable. Second one is if it is secure. And third one is if it is reliable. Right? Affordability means how expensive or how cheaper it is. Security is whenever your traffic is going to um, flow in the publicly available network, because until unless your traffic is traveling internally from here to here or from here to here, right? It's it's safe. As soon as your traffic enters the PE and then travels somewhere else, it becomes vulnerable because it is using the public transport, and then the same provider edge router might also be connected to a few of the other customers that that particular service provider has. So you need to ensure that security is there. And then you have a reliability, like the quality of link, how fast the traffic goes from one point to the other point, and how often this um, service is kept live. We also know SLAs, right? In our industry, they are very important. So when you subscribe for commodity circuits like broadband or like in lease line or commodities lease lines or so on, then you meet the goal that it is affordable. You meet the goal also that it is secure, but you cannot say it is reliable. Affordable because it is cheap. Secure how? Because you can dedicate your network engineers or team of engineers who will build the overlay tunnels. Like, so you will encapsulate the traffic from here to here using an IPsec tunnel. And you will make the communication between branch 1 and branch 2 secure by configuring IPsec tunnels, which are virtual tunnels to forward traffic if it is meant to be delivered to your other destination. So network engineers do require a good amount of time researching how what the current configurations are, researching how the traffic flow really happens, and then design, you can say, a secure overlay network for that. And reliable because we don't say that it is reliable because there are other better performing assets that the ISP has. So instead of subscribing for the commodity circuits, if the organization subscribe for something like MPLS, right, multipath label switching, then in that case, multi-protocol label switching, sorry, then in that case, it is not affordable, but it is secure and it is reliable. Why so? Because when you subscribe for the MPLS type of network, then the provider dedicate a special set of hardware for your connections, and then you will have secure overlay tunnels built between the provider edge. So your network engineers do not need to worry or do not need to configure anything. Earlier, it was kind of a you can say it was costly to dedicate a team of network engineers or hire even higher team of network engineers at a particular branch so that they can keep an eye on how the IP sec tunnels are working and how the communication is working and if everything is all good. But here now, because the tunnel which will be formed between your provider edge device and provider edge by subscribing to the MPLS type of link will bring up the security or will take care of security as well as uh, since MPLS is built on specialized hardware, it can forward traffic from one point to the other point in the most reliable way possible. So that's why we say it is reliable also for traffic types like QoS or I mean traffic types like voice and video traffic and so on, where the retransmission is kind of not an option. So in such cases, MPLS using MPLS always makes sense, but it is again expensive. So how does SD-WAN solution help you here is the SD-WAN solution when you're gonna implement SD-WAN solution. Number one benefit that is gonna give you is all the branches. If you have two branches, if you have 20 branches, if you have 100 branches, if you have 1,000 branches or thousands of branches, all the managers of your entire fabric, of your entire organization, irrespective of whether they are deployed, right, in the world. If the underlay reachability is there, if the ping from one vanish to the other vanish is going, then the IPsec configuration, the reliability, security, everything is going to be taken care of automatically. Makes sense? That's one of the benefit, one of the major benefits of the SD-WAN solution. Second, it has transport independence, which means the level of security and the connectivity that you get over INET, the same level of security and connectivity you will get over any other link. It is just a matter of quality, right, of how your traffic is going to be forwarded. So you do not need to worry about forming the overlay tunnels and all that stuff again, right? And these are then you have controllers like vManager and others which are communicable by using programmatic infrastructure. So you can use a REST API to programmatically configure your environment and all that. Then another benefit that you have is you will be able to manage the entire fabric from a single pane of glass, which means you just so if you have hundreds of devices which are deployed in the WAN environment, you can manage all the configurations and monitoring and everything from just a single pane of glass, which means you can just log into the vManager GUI and you will be able to configure anything. If you want to configure maybe OSPF or ACL on a particular device, you can do that. If you want that configuration to be done on hundreds of devices, you can do that, right? Everything can be done with that. So this is where the SD-WAN solution excels. This is where organizations wants to implement SD-WAN solution in a neat and clean manner. Questions any? Please feel free to ask. Aditya, Anil, Bharti, others, anyone any questions? Looks good. Perfect. Ditmar, I hope you understand that. Yeah, I see a thumbs up. So this gives us a clear idea of the very initial understanding of what SD-WAN solution is all about, right? However, we're going to dive much deeper by understanding the components, by understanding the architecture, by understanding how control plane, data plane operation works and all that. This is just a baseline understanding. This is exactly what we wanted to talk about on our second session. So, which wraps it up. Yeah, I will kind of suggest you to watch the recording of today's session again and again, like at least twice, so that you understand what I tried explaining you with SDN, right?